flywheel, connecting rods, spacers, crankshaft, bushings and crank. Let's make them. Hi all, my name is Lee and welcome to the channel. So, previous video we made the cylinder block and the valve block and I've put those on there, all looking good so far. And today we've got a load of different miscellaneous items we need to make, connecting rods and flywheels, cranks, things like that. So what we'll do is we'll take a closer look now and I'll show you what I've done and what stock I've got to make the parts required. So the first thing I think we'll try and make is the flywheel. It calls out a lot of aluminium in the plans, but I don't have a piece that big, so I'm just using a piece of steel. This is going to be a lot heavier, so it'll be harder to start, but once it's started, the weight of that should hopefully keep it going quite easily. For the connecting rods, I didn't actually have a flat piece of steel available, so I just cut a piece from this round bar, just a cheap round bar of steel, and then I've filed the edges just to make them flat on one surface. That should work absolutely fine for this. I may consider flattening the other surfaces as well, just on the edges, just to make it easier to put the pins through, but it shouldn't make any difference really. For the crankshaft, I've actually got a box of cheap stainless steel rods, and one of those is already 6mm, so I'll use that because it's already been polished, it's nice, so that should work perfectly for the crankshaft. And then for any of the brass pieces, for example, I don't have bronze, I'm using brass, but I have some brass 10mm, and I'll make the bushing from that. Finally, the crank I'm going to make out of aluminium because I do have aluminium available. But we'll work on that later because that's a little more complicated, that part. But to start with, I think we'll go with the flywheel. There's a couple of holes we need to make and I just need to prep this stock on the lathe, make the holes, and that should be the flywheel done. So let's jump on the lathe now. So first I'll just face this off, tidy it up a bit, put a 6mm hole, so I'll do 5.5mm and then ream to 6mm. But I do need to put an offset hole in here for the valve connecting rod, the valve body connecting rod. I'm not sure how I'm going to do that. I could shim on one of the jaws or I can put it in the milling machine, but I'll decide that later. First, let's just get this tidied up. 5.5mm hole, 6mm reamer. I'm going to try and part this off. Hopefully this parting tool will get through there. If not, I do have a bigger, more sturdier one. But let's try it with this. I've left enough stick out so it should be able to make it through. So I need to put a hole for the valve connecting rod at a specific distance from the centre. So to centre this, I've just put it on some parallels and a V-block just to hold it tight. But I'm just going to try and find the centre just using this 6mm pin so I can get it in the hole. Okay, so that looks good. I've found the centre. So I now need to put a 2.5mm hole 6.5mm away from the centre. The reason I need a 2.5mm hole is because this is supposed to be an M3 thread to hold the pin. So let's do that now. Just going to use the M3 tap. So that's the flywheel complete with an M3 thread. Everything lines up nicely, it looks good. I've given it a quick sand, but I'm going to tidy all the metal up before I put it together at the end of the project anyway. So for the next one, I'll do the two connecting rods, piston, which is slightly shorter than the valve connecting rod. So these are relatively simple. They're just 3mm diameter holes. The only odd thing on the valve connecting rod is they've got an oddly specific measurement for the distance of the holes from the edge. 3.708 millimeters on one and 3.707 millimeters on the other. Now I've got a feeling that could just be a mistake on their translation from the imperial measurements. That's my guess. So I'm not sure what to do here. What I'll do is I'll, just round it slightly. I'll do 3.7 millimeters for each one. But to get that accurate, I'm going to have to put that on the milling machine and use the drill. So let's drill the holes in these. So on the plans, they give the measurements from each edge. So that's assuming that you've got the length of the component exactly the right length. What's actually better is just to measure the distance between the two critical points. And in this case, it's the holes. So what I'm going to do is put one hole in, and then I've worked out the distance to the next hole according to the plans. And that should give me the exact dimension. So the two connecting rods are done. The next thing is I'll move on to some of these bushings and spacers. Now, the only thing I need to be slightly careful of is my frame is actually a millimetre thinner. So in theory, I'm guessing some of these might have to be slightly smaller, but I'm going to make them to size. And when I put it together as a test, I'll just file down anything that's too long to make sure everything aligns correctly. So let's do the crankshaft first, because that's quite a simple one. I already have a stainless steel rod, 6mm, that's already polished, so I'll just use that. Brass bushing, 10mm OD, 6mm ID, 12mm long. Two brass spacers, 5mm OD, 3mm ID, each one is 5mm in length. These components are looking great at the moment. The crankshaft I should just be able to glue into the flywheel and the piston crank itself. So that's looking good. The bushing fits perfectly in there as well. Really smooth, a really nice fit. So the next thing we need to do is work on this crank. I've already cut the disc for it with a 6mm reamed hole again. But there's a couple of things I need to make sure I get correct on here, and it's actually the radius that's been cut into the crank. So I don't actually have a 14mm drill to do a 7mm radius circle on there. I actually only have a 13mm drill. So that's what I'm going to use. It's going to be slightly smaller than that radius, a 6.5 radius instead of a 7. But that's absolutely fine. That should work because that's the only tools I have available. I just need to be careful of the offset, where to drill these. And also in the same setup, I'll also do a 2.5mm hole for the M3 thread on that edge. So I've just noticed, I mean, I'm looking at the plans upside down because I'm recording, but it doesn't give me the distance of this M3 hole from the center. Unless I'm going mad, I cannot see that. It's given me the distance of these holes, but not the crank pin. So what I'm going to have to risk is these plans appear to be to scale, or at least some of the diagrams are, because if I measure this 11.5 millimeter, it is about bang on 11.5 millimeters. So all I'm going to do is measure this distance, and that's the distance I'm going to have to go for. It looks to be around 9.5 millimeters. So that's what I'm going to go for. So I've already found the center and I've reset the draw to 0. The first hole I'm going to do is the small 2.5 millimeter hole for the M3 thread that I've just worked out should be around 9.5 millimeters from the center. Now this isn't the strongest setup, but this first hole should be fine because it's pressing against the parallels. Now the issue is going to be when I use the 13 millimeter drill to create those radius. That's going to be pressing over the edge. I need it over the edge for clearance. So I'm going to have to invent some sort of elaborate clamping system to put something on the back of this disc to stop it being pushed when I use the big drill. Okay, so this is the best I could come up with the tools that I have. I've got one of those cheap Amazon clamping kits. I'm using one of the holes on the vise, the movable jaw. And I've just got a couple of spacers in there and I'm clamping that down on top. I'm hoping that's now going to be strong enough to let me drill out the 7mm radius. So there's only one way to find out. Let's give it a go. Last thing to do is put the M3 thread on. Well, this piece worked out really well in the end. I'll probably need to get some bigger end mills because rather than using the long drill, that would have been better to plunge with a larger, shorter end mill to give it more stability because it was rattling for a second. But I got the job done slowly but surely and it's looking really good. So now what I'll do is I'll just assemble what we've got so far. Just going to use some small cap head screws just as the pins for now, but I'll probably end up making some threaded brass pins for the final piece. But for now, let's just use these. So it's looking really good so far. So I'll bring this video to an end. Please join me on the next one where we pretty much finish off. This is the final components. We make the piston and also the valve, and I'm going to make those from brass. So join me next time and I'll catch you soon. Cheers.